All right, continuing on with our practice questions. We have an RC series circuit with our V total, so that's our V max of 12 volts, our resistor of 1.26 mega ohms, mega is times 10 to the 6, and then a capacitor of 1.70 microfarads, and again, micro is 10 to the negative 6, so make sure we're changing those beforehand. Okay, so the first thing that's going to ask us to do is calculate the time constant, right? So our time constant is tau, and that is going to be RC. So we're going to multiply those two together to get our time constant. Then it's going to ask us to find our maximum charge. Our maximum charge, remember, goes back to our capacitor equations, where our Q max is equal to our capacitance times our total voltage. So C is where it gets kind of interesting. So let's go ahead and answer A and B first, and then I will walk you through C. Okay. So when we're calculating our time constant, we're going to do 1.26 times 10 to the 6 ohms multiplied by 1.70 times 10 to the negative 6 microfarads. And so and again, that tau is our C. Doesn't matter whether it's charging or discharging, that is your time constant. So now we're going to find the maximum charge that will appear on the capacitor. So again, our charge max comes from our capacitance equations. That's our total voltage or EMF. And so once we multiply our capacitance with our 12 volts, we're going to get a maximum charge of 2.04 times 10 to the negative 5. So it's important to make sure we're reading questions carefully. I personally, you've probably noticed, I like to highlight or underline. If you want to print these out and do that by hand, that's fine. Or even write out given information. But the maximum versus at a given point in time really makes a difference, okay, on what equation you're using. So how long? How long means we're looking for time. How long does it take for a charge to build up to 7.92 microcoulombs? Note microcoulombs. What is that? That is a charge at a given point in time. So we're not finding the charge at a given point in time like we were going to in the previous ones, but we are actually determining how long this takes, okay? So what we're doing is we are going to use our charge equation, which is Q at any given time is equal to Q max, and this is charging, so we have 1 minus e to the negative t over tau. I'm using tau this time because I know tau, right? It was given, or we had to calculate it in part A. So now I'm going to plug in some numbers. I've got 7.92 times 10 to the negative 6. Because that was given to me in the question. My maximum I found in part B, which is 2.04 times 10 to the negative 5. And I'm going to multiply that by 1 minus e over negative t. I'm just going to write tau for right now because I'm going to walk you guys through this. We know tau is, what is it from our previous one? 2.14 from our part A in our question, okay? So now we need to remember our algebra. All right, so because of these parentheses, I can go ahead and just divide out both sides. So I'm going to divide 2.04 times 10 to the negative 5 from both sides. Please make sure you're using parentheses. That is a common mistake. If you don't use parentheses, it'll multiply that 10 to the negative 5 instead of divide. I'm going to keep 3 sig figs, so I end up with 0.388 is equal to 1 minus e to the negative t over tau. Now, algebra, right? I'm going to subtract both sides. I'm going to subtract 1 from both sides, so I get negative, so I get 0.388 minus 1. Negative 0.612 is equal to negative e is t over tau. So I'm going to multiply both sides by negative in order to have them both positive. Yes, I'm showing multiple steps here, but that's okay. Rather show too many steps than not enough. Okay, so this is where we're like, now what do we do? If you remember the opposite, I mentioned at the beginning of the lecture, the opposite of E is natural log. So if we take the natural log of both sides, then we're going to end up with negative 0.491 is equal to negative t over tau, and our tau is 2.14. Okay? So once we're here, we have negative on both sides, so we can multiply both sides by -1 to make them both positive, and then we can bring that 2.14 up to the other side. So I'm going to multiply 2.14 and 0.491 to get a time of 1.05 seconds. So that, my friends, is how we solve for time in a charging or discharging question. And there it is right there. Okay. Okay. Fun with math in this unit. All right. So there we go. Okay. I believe this is our, maybe we have one more, but here's another practice question as well. This one we are going to discharge. So the figure shows an ideal battery with an EMF of 13 volts. So we've got 13 volts over a battery, a resistance of 6.3 ohms, and a fully charged capacitor with a capacitance of 3 times 10 to the -6 farads. Okay, so we'll just put 3. I like to change those right away just so you don't forget to do that later. After the switch is closed, what is the time it takes to discharge to a charge of 0.25 microcoulombs? Okay, so what do we know here? This is the charge, right? So that is the charge at a certain time. We're going to know that. We're going to know our total EMF, as well as we can calculate our total maximum charge. Okay, so we need this max. We need this we know is 13 volts. This we know we can multiply those two together. Okay, now this is where you could either solve for tau and plug it in the exact same way we did before, or we could use your RC in that situation. So once again, you've got your charge at a given time is going to be your charge maximum. Now, this is a discharging, so there's no 1 minus. It just goes e to the -t over, I'm going to go ahead and put RC in there because I don't know what tau is right now, and I don't necessarily need to, right? So then I'm going to do my charge at any given time over my charge maximum. Charge maximum, again, you have to calculate that. And that's going to equal over RC. Okay. And so then you can go through this and determine what your time is, right? So once you calculate this, you're going to take the natural log of both sides. And so this is and that's going to equal -t over RC. And then we solve for t. Okay. So when we do all that properly, we should end up with a time of 9.5 times 10 to the -5 seconds. Now, I'm not walking you through it. Well, I walked you through most of it on that one. But please make sure that you're actually plugging these in yourself. You're using the correct values in each case. And, you know, as I said, if you're rounding as you go, try to hold 3 sig figs. That's what I'm going to do when I make my answer keys. But that's how we're going to solve for that one. Okay, so please make sure, as I said, you're trying these practice problems on your own. I may create a few more examples that I'll post that you can use in order to make sure you know how to understand how to do these.